Hi, everybody. I'm going to go over the analysis questions for 0106 with you guys, if I could, and also give you the unknown period that you're going to need to be able to answer any last questions that you might have on that document. To do that, though, I wanted to give you an example. So I put together a graph, a scatter plot that you can see here on the slide in front of me. It has, just like you have, it has the mass listed on the x-axis and the period of a single oscillation on the y-axis. So I've created the scatter plot from a data table. I can see the fit is pretty good for that linear trend line because I added that linear trend line. And then I also added the equation right here. If you've forgotten how to do any of that stuff, I noticed that quite a few people in the class were able to do it. So my suggestion is the easiest possible way to do it for yourself tomorrow is to, today, is to go ahead and ask somebody else in the class for assistance. There's plenty of opportunities to look it up if you want to, or to check out videos if you need to, but probably the fastest way is to get information from the people around you. In any case, you should know how to create a scatter plot, you should know how to add a trend line, and you should know how to include the equation for that trend line by the end of this period. That's kind of part of what we're doing. And like I've said in the past, we're going to go ahead and do this often in these labs. So please make sure that you know what you're doing. Okay, so here I have my equation, and my equation looks funny. It's got an equal sign here, and then it's got an 8.19 e negative 4. 8.19 e negative 4 is calculator speak for 8.19 times 10 to the negative 4th. So I'm going to convert that to a decimal just so you guys can see what it looks like. You probably have a similar style kind of number there, some number that's in scientific notation. And so you want to go ahead and convert it to a decimal if you want, or if you're familiar with how to use scientific notation on your calculators, you may want to go ahead and use it just as it is. Anyway, so it's 8.19 times 10 to the negative 4th times x, so my x variable, plus 0.3141. Now, it's a little weird because the equation doesn't have anything on the left side of it. And so I want to convert it into, I want to show you that this is what it actually means. So if you go ahead and take a look at the slide now, you can see that I've converted it into the equation for a line. And the equation for a line in this case is in y equals mx plus b format. For those of you who've forgotten, m is the slope and b is the y-intercept. And so the slope of this line is 0.000819 and the y-intercept is 0.314. What that would mean is that if there was no mass added to your balance, you should find that the period of oscillation, or I should find for mine, is 0.341 seconds per oscillation. So that's really what that means. The 0.000819 talks about how much the period of oscillation changes with mass. So that's again the slope. Anyway, so what can I do with this? Well, first off, I have to realize that the y variable in this case is the period of oscillation and the x variable is the mass. So I'm going to go ahead and replace the y with period and the x with mass so that you guys know, so you're not confused by the y and the x, where those come from, right? They're actually period and mass. So once I do that, I have to solve it for mass. So I'm going to go ahead and rearrange the formula so that it's solved for mass. It looks like that. All I did was use algebra to solve that formula. I subtracted 0.341 from both sides and then divided both sides by 0.000819. And this is what I ended up with. You can also see that I flipped the side so that mass is on the left now and period is on the right. That shouldn't make a difference to you though. That formula is in the proper format for what we want to do. So I'm just about to give you the period of oscillation for the unknown. You're then going to plug it into the formula and use that formula to figure out what the mass is. I want you to think just for a minute how amazing this is that you're able to do this. So you're able to take something, a series of known masses, and shake them, and as a result then produce a mathematical relationship which you could then use to convert any period of oscillation on your device into a mass, which I think is pretty cool. And this is exactly what they do on the International Space Station with that goofy swing that you saw the astronaut bobbing up and down on. They already have it calibrated in such a way that they already know what the equation is, and so they can convert a period into a mass in a similar fashion. Anyway, so here's the unknown, the period, the moment you've been waiting for. Just use 0.500 seconds for the period of the unknown. So you may have data that's close to that. That's totally fine. In fact, you should have a data point that's pretty close to that, but this number should be slightly under that. So hopefully that'll work. Anyway, for me, I'm going to go ahead and plug in that 0.500 value for the period right here. So I'm going to end up with a formula that looks more like this. So 0.500, which is the unknown, minus my y-intercept divided by the slope, and I end up with a mass of 194 grams. 3 sig figs on this, so I have to make sure to include all that stuff. So that's my period, that's my mass for the unknown. Again, I converted its period of oscillation into its mass, which I think is pretty cool. Coming down here to the rest of the analysis questions, what's the nature of the relationship between these two variables? It's positive and direct, right? It's a linear relationship, and it's in the upward, it's up and to the right. So it's a positive relationship. Positive and direct is what we're talking about there. Step 3 up here, what's the formula for the trend line? We just talked about that, so hopefully you can write your own formula in there. Step 4, what's the period of oscillation for the unknown mass? I just gave it to you. It's 0.500 seconds. And then last, can you do the calculations for your own unknown, for your own equation with that unknown mass to be able to figure out what the period should be? Anyway, at the end of this space right here, you should have a number in grams that makes sense. For me, 194 grams makes sense because when I plugged in my data table, my faked data, my 200 gram mass had a period that was pretty close to that. So it makes sense. I've confirmed it. I've gut checked it. I feel good about it. And so hopefully that makes sense for you as well. That's really it. Once you've got that done, you've got your scatter plot here and you've answered these questions. Go ahead and turn it in. Remember, each person should turn in their own just so I can see that you've had a little practice with the graphs. And then move your way on to 0105, which is the virtual version of this where you do kind of the same thing. Good luck with that. Please let me know if you have any questions.